Okay, we're going to go over problems 6 through 10 from the 2016 Algebra 2 exam. Looking at number 6, I think that this was actually a pretty basic question based on what we've done in class. Remember, when you see a number outside, we're no longer talking about the square root or the second root, but we're talking about the third root. And it'd be good, based on all my answers, if I look at all these answers, I'm seeing exponents, and I'm seeing a fractional exponent here. So it might be good to change, in this case, instead of how it's written here, to rewrite it as 27, a to the negative 6th, b to the third, c squared, and all of that to the 1/3 power. All right, because third root is the same as raising something to the 1/3 power. All right, so now when you're raising a power to a power, which you're doing in this case because all of these inside the parentheses have powers, including the 27, which is just 1. When you raise a power to a power, you multiply these. So you multiply this, then you multiply this, then you multiply this, and then you multiply this. So if we do that, you end up with 27 to the 1/3. And then when you're dealing with the A, you do negative 6 times 1/3. Well, negative 6 times 1/3 is just negative 6 over 3, which is negative 2. So this is actually going to be A to the negative 2 power. And then we have B. 3 times 1/3 is just 1, so we just have B to the first. And then you have C to the 2/3, because 2 times 1/3 is just 2/3. Now, obviously, I don't see that answer anywhere, and you don't see any negative exponents. Remember, dealing with negative exponents, if A to the negative 2nd was by itself, that's the same as 1 over A to the positive 2nd. So when you're dealing with this one we have over here, we can keep going and say, okay, 27 to the 1/3, and then we can do B, and then C to the 2/3, and all of that over, we can move A down to the bottom, and make it positive, make the exponent positive. Remember, if you have something where it doesn't look like it's a fraction, remember, you can always put it over 1. So this one I could really put over 1. And so I move my A squared down to the bottom. And now I have 27 to the 3rd. Now hopefully you remember that this one right here, 27 is a perfect cubic number. And so for 27 to the 1/3, it's what times itself 3 times gives me 27, which in this case it would be 3. So you're going to have 3, and then B, C to the 2/3, and then over A squared. Now, let's see if we see that. Looks like we do see that, and your answer is number 1. So that's for that. Okay, number 7 is pretty straightforward. I'll read it really quick so we can understand what's in here, or what it's talking about. It says the amount of money in an account can be determined by the formula A equals PE. Remember we talked about that E, that's just a constant, all right? That's just a constant. PE to the RT, where P is the initial investment, R is the annual interest rate, and T is the number of years the money was invested. What is the value of a $5,000 investment after 18 years if it was invested at 4% interest compounded continuously? All right, well, you have our formula right here, so I'll just go ahead and circle that and write it down. And I want you to think about how many variables you have here. In reality, you only have, you have 4 variables. You have the A, the P, the R, and the T. The E is not a variable, so don't think of E being a variable. It's a constant. Remember, in your calculator, your E is actually going to be this. So I hit second, and then and this little bun right here. Remember that number? We talked about that earlier in the year, 2.718, dot, 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 dot. So it's just a constant. It's not a variable. So the reason why I say that is because in order to solve this, or for any one of the variables, you have to have at least 3 of the 4. So in this case, we have the value of a $5,000 investment, which means that's going to be our P. Because that's our initial investment. The time's pretty obvious, 18 years, right here. And the rate is 4%. Now, what you have to be careful of is when you deal with the rate, you don't put in 4 for R. You have to, whenever it's a percentage, you have to change that. So 4% would be the same as 0.04 as a decimal. So be careful. And don't do 0.4 either. That'd be another mistake. All right, so in my calculator, I'm going to plug in 5,000. We're solving for the A, so we don't have to do any type of moving around. All we have to do is plug stuff in. If we were given A and we were looking for P, we'd have to do something else. Or maybe we were given A and P and looking for R, or something like that. But right here, we're given P, R, and T, so it's pretty straightforward. We do 5,000, then we do second E. Let's go back here. And then, so I'll actually write down what we're actually putting in. A equals 5,000 E to the 0.04 times 18. Let's go back. 5,000 times E times 0.04 times 18. And his answer, and looks like our answer is number 4. So number 7, the answer is 4. All right, let's look at number 8. All right, looking at number 8, we have subtraction of fractions. Don't have a common denominator, so I would look at these and I would say now there might be multiple ways to do this. I'm sure that there is. So if you think of another way, or someone says there's an easier way, I'm sure that there is. I'm going to do it the way that I did it when I looked at it. All right. First of all, I know we don't have a common denominator, but I'm looking at this 2, and if I factor this, this would be 2 times 1 minus x. Now I like that 1 minus x. However, I don't like it. Well, I thought I liked it, but 1 minus x and x minus 1 are not the same thing. So be careful, because you might be tempted to think, oh, well, 1 minus x and x minus 1, same thing. All I need to do is, have that factor of 2. Well, that's not the case, because 1 minus x and x minus 1 are not the same thing. So what you can do, and what I did, was I rearranged this second fraction. So I took 1 over 2 minus 2x. And I wanted to make it look different. So what I did was multiply it by a form of 1, which is negative 1 over negative 1. Remember, that's a form of 1, so you're not changing the value of your fraction when you do that. But you are going to change how it looks. So now that's going to equal, over here, negative 1 over, and when you do negative 1 times all this, you end up with negative 2 plus 2x, and you can write negative 2 plus 2x, that's equal to 2x minus 2. All right, so now I have a new fraction, which is still equivalent to the original one. That's the key. So now I'm writing this down right here. I did not change that, but I did change this, so I'm going to write, I changed this one into this. So now I'm going to have, don't forget your minus, because I'm writing that right here. All right? I'm writing a lot of stuff. I don't want to be confusing, but. Okay, so we have minus negative 1, don't forget that negative, over 2x minus 2. All right? So now I'm going to go ahead and factor this. This one right here, I'm going to factor that, so I'm going to have x over x minus 1 minus 1 over, now when I factor that, I get 2 times x minus 1. And don't forget the negative. Okay, now, if you notice, looking at this bottom and this bottom here, you end up having, the only thing that's missing is this 2 right here. So what I need to do is multiply this thing by 2, and then multiply the top by 2. So what we end up with is 2x over 2 times, I'll just keep it, you could multiply it out, but I'll keep it in parentheses right now, minus a negative 1 over 2 times x minus 1. All right, now, remember, when you have a fraction, or when you're subtracting or adding fractions, and you have the same denominator, you can combine the tops on top of the denominators and make a single fraction. So this is going to be now 2x minus a negative 1 all over 2 times x minus 1. So this on top is going to give us 2x plus 1 over 2 times x minus 1. And let's see if we can see that up on the top, any equivalent value. All right? Yeah, it looks like it's number 3. So if you had multiplied it out and you had, let's just say you had multiplied it out and you had gotten 2x plus 1 over 2x minus 2, you'd have to look up at the top at number 3 and recognize that that's the same thing. All right, even though the denominator here looks different than our denominator down here, you'd have to recognize they are the same thing. So that's your answer. All right, let's look at this problem. What is the total number of points of intersection of the graphs of the equations 2x squared minus y squared equals 8 and y equals x plus 2? All right, so looking here, we have y equals x plus 2. So we know what y is. Now over here, we don't have one of the variables by itself. So let's look at this one. We know y is equal to x plus 2. So we're going to take this part, and we're going to plug it in right here. And so our equation is going to be 2x squared minus, now we're going to put this in for y, x plus 2 squared equals 8. Now we're going to multiply. Don't distribute the negative, which would be multiplying. So don't do this before you deal with the exponent. Be careful, because really the minus is just being multiplied. So we want to deal with that. So you want to deal with x plus 2 squared. Right, so we're going to have 2x squared, then minus, and all of this in the parentheses is going to end up being x squared plus 4x plus 4. Remember, you got to do your FOIL or double distribute, whatever method you want to use. And now we need to distribute that negative. So this negative now needs to come, and you're really multiplying by negative 1. That is what you're doing. All right, so we're going to have 2x squared minus x squared minus 4x minus 4 is equal to 8. So now we can combine like terms. We have this one and this one like terms. Those are the only like terms we have. So we're going to have x squared minus 4x minus 4 is equal to 8. Now I'm going to go ahead and set this equal to 0 because it's quadratic. 8 minus 8, so x squared minus 4x minus 12 is equal to 0. And this can factor. You can use the quadratic formula, but so the two numbers that multiply to give me negative 12 and after negative 4 are negative 6 and a positive 2. And so that means our x, my x is going to be 6 and negative 2. That's really what that's saying is that those are the two places that intersect. Let's check these. Let's see what happens when you plug these back in to your original equation. So I'm going to try x is 6 and x. First I'll try 6. So when I plug into this first equation, I have 2. I'm going to erase this stuff here. So if you have 2 times 6 squared minus 5 squared is equal to 8, and we end up with, so this is going to be 2 times 36 minus 5 squared is equal to 8. Then you end up with 72 minus 5 squared is equal to 8. And when you, alright, so I'm going to subtract 72, I'm going to get negative y squared is equal to 64. Negative 64, right? When they're both negative, you can really just cancel those out and have y squared is equal to 64, and y is equal to 8. And also, it's also equal to negative 8, but we're not going to, that one is not going to be relevant in this case, because when we plug in this 6 here, we get y is equal to 8. So we have one point to where they intersect, 6, and then when you plug in your negative 2, I'm not going to do that here, but if you went ahead and did that, you would see both your y's would have the same value just as with the 6. So your answer is, for number 9, 2. All right, going to do number 10 now. I want you to write down this definition of a common difference. So I want to see that somewhere. So go ahead and pause it, write that down. Also, I'm going to go show you some examples of arithmetic sequences, which this is. So let me look at a couple of those here. So if you look, so I can't write on it while it's here, but you can see these are some pretty basic ones. I mean, you know, I touch that one? Yeah, so look at that one. That's very basic, but it is an arithmetic sequence, and the common difference is 2. Here, the common difference is 3. So if we go here, we have a much more complicated one. So let's just look. If you have one that's 2, 5, 8, 11, blah, 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 blah. The common difference is 3. So looking now, so let's just look at our question. Let's read the question. Given the sequence x, x plus y, x plus 2y, which expression can we use to determine the common difference of this sequence? Well, you know, if you look at these, one way you could find the common difference all the time, I mean, it looks pretty obvious when you have 2 to 5, and you have 5 to 8, and you have 8 to 11. You know, that's pretty obvious that it's plus 3. But what if you have something a little bit more difficult, one way you can always figure it out, if you know it's an arithmetic sequence, you can just do 5 minus 2. Or you can do 8 minus 5. Or you could do 11 minus 8. Okay, that's another way you could do it. So looking here, if I look at these answer choices, if you notice answer number, well first, I mean, if you want to think about it, what would the common difference be here? It looks like from here to here, what's being added, and then from here to here. It's got to be the same thing every time. So hopefully you're recognizing after a second. Well, first of all, take a second to think about it. Pause it. Okay, I'm going to give you the answer now. It's just being added y. X plus y, it gives you x plus y, and then plus y. Right? But they're not asking what the common difference is. They're asking which expression can be used to determine the common difference. So if you look here at number 2, they actually have this one here minus this one here. Right? And when you do that, you end up with, let's see, I'm going to erase this now real quick. If you end up doing this, hold on one second. Be right back. All right, if you know your common difference is y, you could do all of these and you're not going to get y. You're only going to get y as a value in one of them. And if you do, well, let's look at the right answer here. If you do x plus 2y, and then you do minus x, and then minus y, if you combine all that, the x's cancel out, because x minus x, and then 2y minus y, all of that is going to equal y. All right, but let's look at the other one. So your answer is actually number 2. All right, now the other ones, if you do, I'm not going to look at all of these, but if you look at the first one, if you do x minus, and this is going to be x minus y, this cancel out, and your common difference is not negative y. So that's not your answer. And on 3 and 4, nothing's going to cancel on 3 and 4 anyway. So, and those are definitely not your common difference. But, you know, if you look here, there's a lot of ways to go at it, so I'm not going to go over all of them, but there you go. So that's the next 5 questions on the January 2016 exam.